All right, so the last time we were here, we were looking at, so we went over kind of how to present data, right? So just a quick overview of where we're at here. So we started off here with this set of data here, right? We had these different, excuse me. All right, so we had these different, so we had a study here, right, where we asked 28 college students, all right, we're asked to name their preferred browser, and we were given just the data here in kind of raw form here. And the goal was to kind of change this and present it in a much more easy to read form, right? And we did that using three different ways to do that, right? The first one being what we called a frequency table or frequency chart, all right? And in this case, we said, all right, using this frequency chart, we kind of broke down, this was qualitative data. So we had 4 different results, and then the frequency was how many times, right, the students answered Safari, Explorer, Chrome, or Firefox. Okay, and that was a frequency table. Now, in terms of charts, we looked at a bar graph, which here again, along the vertical axis was the frequency, right? And along here, the along the horizontal axis, we had the our data values. All right, in this case, the types of browsers. All right, now, when we don't really pay attention to what order we present our data, we just call that a bar graph. Now, a particular instance when we order it in such a way where we have the highest quantity to the lowest, right? This was an instance of what we call the Pareto chart. All right, same as a bar graph. The only thing here is that here there's an order as to how the data is presented, right? It looks a little cleaner, right? And that's really that is the only difference between a bar graph and a Pareto chart. Okay. All right. Okay, so we also looked at a different chart, a different type of visual representation, which was a pie chart. All right, so in this case, this was kind of broken down into kind of percentages of which the data, right? So in this case, Chrome was 12 out of 28. So that's where that 42.86% came. And that's kind of represented there in our pie. All right, now, one thing here, the bar graphs and the Pareto charts, they're easy to do by hand. The pie chart, if we're gonna use a pie chart, then I would suggest using kind of Excel or Google Sheets or some kind of technology to help us have a nice little graph like that right there. Okay, now, today, we're going to move on to, so Monday's example was only using qualitative data. So now we're gonna look at quantitative data. All right, so in this case, quantitative data is numerical values, right? So several children, so for this example, several children were asked how many TV shows they watch each day, and the results of the survey are shown below. Okay, so here we have number of TV shows and then the frequency, right? So it's already given to me. So it's not in raw form, we have a frequency table. All right, so they give me that frequency table and I want to change this into a chart or some kind of graph, I should say, excuse me. All right, now, since we are dealing with quantitative data instead of qualitative, we're going to do a bar graph, but when we're dealing with a quantitative data, we don't call it a bar graph. What we're going to do is something called a histogram. All right. So a histogram is like a bar graph for quantitative data. All right. Okay, so it's a bar graph for quantitative data. So I'll start off the same way that I started my bar graph is, let me draw some axes here. And so we'll start off here. All right, so I'm gonna use this ruler function and kind of clean up my graphs from Monday. Those looked a little sloppy, so this should kind of clean things up a bit. All right, so there we go, nice and straight lines now. All right, okay, so now one thing here is that when we were dealing with bar graphs, we had a Pareto chart and just a regular bar graph. But here in this case, we are not gonna have that, right? Because it's numerical, so there is already kind of a natural order for this, right? It's gonna be in the order of whatever our data values are, right? Now, the vertical axis is still gonna be the frequency. All right, and then the horizontal axis will be the data. In this case, the data is number of TV shows. All right. Okay, so here we look at number of TV shows, so I can space it out. Again, I don't want all the numbers to be kind of bunched up, and so I want to give myself plenty of space to draw this bar graph. Number of TV shows is going to range from 0 through 4. So here we'll say, all right, first one is 0, 1, 2, 3, 4. Okay, so I don't want to bunch them up, and I want to keep them equally spaced. Here I kind of, it's just kind of eyeballing the equally spaced, but we could see 0 through 4 there. Now that's the number of TV shows. Now on the vertical is going to go the frequency. So I want to give myself enough space to go up to 36. Okay, so here I think maybe the best way is kind of use tick marks by 5. So we'll go 5. Okay. All right, so let me write this a little neater here. Okay. All right, so now we have our graph here set up, just the axes and then the labeling of them. All right, and now here the thing that we're going to do here, now here we have to be careful how we represent this data. All right, now the way we're going to read this is if we notice 0, well, I have this big gap between 0 and 1. Right, so for 0 TV shows, I had roughly 12 students, or children, I should say, watch 0 TV shows a day. All right, so the way I'm gonna organize this is I'm gonna have 0 to be the left corner, right? So if I go, okay, so let's say roughly what would be 12. We'll say 12 is somewhere around there, maybe a little bit higher, right? And again, if I were using some kind of technology, it'd be a lot cleaner. But here, if we're drawing it by hand, we're just kind of estimating what we have here, right? So, and then I'll draw a horizontal line. All right, and then let me get my 90-degree angle here. Go down there. All right. Okay. All right. So now notice here, and let me actually adjust this down here. So I'll have 1 go right there. Okay. So one thing to notice here about the Theodore, which chart are we referring to? Zoom out there. Okay. All right. So, okay. So here, one thing to realize here, so notice that even though it goes to 1, the way you want to read this is based on the left corner there, right? So I know that this bar is going to correspond to 0. Okay, so let me kind of make it look a little nicer here. Let's add some color to it. All right. Okay, so, and again, the bar will range from 0 to whatever the next data value is right there. Okay, and now let's move on to 1. So the 1, it goes all the way, children that watched one TV show, that was 18. So again, we'll take my ruler out here. Sure, I'm completely horizontal there. All right, and let's say 18 is maybe somewhere around there. All right, and again, it's going to go from 1. Oops. I've waited to. All right, let me finish this chart up here. Okay. All right. And then that would be, again, right, the way you read this is from the left, right? So I know that this bar corresponds to 1. Okay, and again, let me just kind of shade it in here. All right. Okay. So now let's again move on to the next one. So for 2, we have a 36 TV show. So again, we look at our ruler here. We want to go up to 36. So here. Call it something like that. And again, here at this point, it's just really making sure this looks nice. Okay, and then just color it in here. Okay, all right, and then just moving along, we'll say, all right, we had 2, for 3, now we're at 7. So here. All right, color it in, that's for 3. And then lastly, 4, we had 2. So we'll scroll down. It's probably somewhere right there. And actually, let me 5. All right. Okay. And that'll look something like this, right? Let me clean this up a little bit. There we go. All right. Okay. All right, and that would be an example of a histogram, right? And then from there, again, right? It's just a visual representation of our data that we have in a frequency table. We just now switched it over into a chart form. All right, so also a bar graph, but again, we only call it a bar graph when we're talking about qualitative data. Okay, any questions so far on kind of the this graph right here, or how to generate this graph? Okay. All right. Again, if at any point you have a question, just kind of chime in via the chat bar, or feel free to unmute and ask a question out loud. Okay, so our first set of data was where we just had one number corresponding to one frequency. All right, but let's say that we had, instead of that, all right. Okay, thank you. I'll try to slow down a little bit. Instead of that, we had kind of a class or a interval. All right, so notice here that we again have a frequency table. All right. But instead of having one data point, we have here something that what are called classes, or think of intervals is what we have here. Okay, so now I want to construct a histogram. All right, so again, I'll start off the same way I started the previous histogram. Is I'll have my axes. All right, so let me draw those first. Okay, and again, I start off every asking to construct a histogram. It all starts off the same, right? The vertical axis will always be the frequency. And then here, whatever the data is that we're measuring, the speed in a 30-mile-per-hour zone. All right, I'm shocked that so many people are speeding in these 30-mile-per-hour zones. All right. Okay, so here, the way we're going to start this is, notice that before we started at 0, and that made sense for our data, right? Our data also started at 0. Okay, so in this case, it really doesn't make sense for us to start at 0. All right, the reason being is if we look here, right, the data starts at 42. All right, so it kind of be just kind of not really kind of pleasant if we had 0 here, and then we went to start at 42. All right, so we could start at 40. Right, that would be a okay idea, right? We could do that. Not incorrect. But I mean, we could also just start at 42, right? And notice here that the classes or the intervals are of equal length, right? Which makes things easier, right? Each has a length of 3, right? So we could do something like, okay, well, what if I start at 42? All right, and the next one that I really am going to be worried about is, so I'll choose these values here to kind of label. All right, so notice there that I'll go 42, and then the next one I want to tick off is 46. And so we go, all right, 46, and then the next value is 50. And then 54. And then 58. And we just label the next one, even though we won't be using it. All right. Okay. All right. And again, we could start at 40 if we want. I think here, just to keep everything equally spaced, we'll just have it start at the smallest value of our day. All right. Okay. Any questions so far? All right. Okay. So now let's look at our frequency, our vertical axis. All right. Okay, so here, if we look for our vertical axis, we want to go from all the way up to 25. So we could say, all right, if we do that, maybe let's tick off every 5. 0, 5, 10, 15, 20, and 25. All right. Okay. All right. And again, and then here we'll look at 42 to 45. We'll look at 25. So again, same thing as before. This will be measured from the left, right? So 42, start at 25. All right, and connect it here. Okay. All right, and again, right, now be sure that you're able to read these graphs, right? Not just mine, but as you work through the homework and different examples here. The bar is stretched across 42, and it goes up to, but it does not include 46, all right? The way we always read this is we always read from the left, right? The left highest point, it corresponds to all of those values up to, but not including that 46. Okay, so make sure that when you see something like this, that you're able to read what it's representing. All right, let's give it a little color. All right. Well, I guess here, since one thing to realize here is that kind of the way we interpret these classes or intervals is that we start at 42, and we go all the way up to, but not including 46. Right now, if we think, are we exceeding it? Well, our data, if we kind of measure miles per hour, it's usually measured as integers, or think of whole numbers, right? We never say, oh, I was going 45.5 miles per hour. All right. So we kind of are implying here that we're extending all the way up to 46, right? But really, we want to make sure that we understand that all of these values are interpreted as 42, and you go all the way up to, but you do not include 46. Correct, right? So the next one starts at 46, and it goes all the way up to 49, right? But again, there's no values of 49.5, 50, or anything like that, right? So it stops at 50, but it does not include 50, right? So the next one we would say, all right, so 46 to 49, those would be 14, and we would say, all right, let me draw this here. So let's say 14 is right below 15. All right. And we would draw it like this. All right. No, it's including 49. What it's not including is 50. All right. So it includes every number up to, but not including 50. All right. So when we look at this, it starts again, you read it from the left always. So 46, and it includes 46 all the way up to, but not including 50. All right. So here, let me maybe write that up here. Well, not as a precaution, but really that's how we want to represent our data, right? Our data is inclusive of 45, inclusive here of 46, right? So the idea here is that we're just going to write it as just kind of these bars for my histogram. Right? So when we see something like this, it includes every value between 42, inclusive of 42, right? And again, that's just a convention. We just said, okay, when we draw these charts, we want to make sure we include the left point, all right? And that's really just a convention, all right? We start there, and then kind of like we're reading it along the way, and it goes up to, but it's going to stop at wherever that bar stops. Correct, yes. So there's no interval of 49. And really that also comes into the fact that our data is not continuous, right? We don't have values of, let's say 49.5, right? Or 49.75 or anything like that, right? So, and if we somehow did have those values, then we would include it in those intervals, like right here, right? But in this case, this implied that we just don't have values like that. All right, but yes, these bars, it's showing these intervals up here, right? The first one is 42 to 45. The second one is 46 to 49, right? And then the third one that I'll draw will draw 50 to 53. Okay. Right, so 50 to 53 is at 7. We'll call it right there. right? And again, for 50 to 53, right? So it goes up to, but it does not include 54. Okay, any questions so far? Did I clarify the questions that you have been asking? Okay. All right. Okay. All right. So then let's wrap up this graph here. So our next interval from 54, again, start from the left to 57, right? So up to, but not including 58, right? We have 3. Let's see, right? All right. And then lastly, from 58 to 61, we have 1. So that will. All right. Okay. So our histogram for this data will look something like this. All right. And then later we'll look at kind of describing the shape of what is called the distribution of this data. Right. And then you can start to see kind of words like this kind of a little bit kind of bell shape, right? Where there's a high kind of peak in the middle. And this one is this is called a skew to the right, where some of the extreme values are on the right side of all of the data here. For now, yes. So the first part, and we're going to see later, or actually after this example, we're going to look at numerical values to describe the data. All right. But yes, right now, this is just a visual representation of the data that's presenting to us. All right. All right, good. Any other questions before we move on? Oh, that's just kind of the shape, right? So you think of the shape of the data is bell. It's very close to being what's called bell shaped, where it kind of, not quite, right? But we can kind of see, all right, it has this high peak. And then it kind of goes down, right? Yeah, kind of, it's related to the empirical rule, right? And again, we'll talk more about those types of classifications a little later. I'm just kind of, as a look ahead, to kind of start thinking of here, bell shape where it's kind of peaked. And ideally, we would like for it to be symmetrical, for it to look the same on both sides of the peak. And this isn't quite there, but it's close enough, right? I mean, maybe if we had more values, it might look more like a bell, right? And then something like this, right? Now, this is definitely not bell shaped. the peak happens in the first one. So something like this is what's referred to as skewed right, right? Where the extreme values, and extreme, there's only really one of them here, are on the right side. All right. And again, that's just kind of referring to the distribution of our data. Okay. Any other questions at this point? No. Okay. So good point, right? How is it on the right? So skewed means that where are the extreme values at? Right. So skewed is referring to, when I say skewed, no, not. So when I say extreme, I mean which ones are not likely, right? If you look at our chart here, all of the likely ones are right here at the beginning, right? But what I mean by extreme is something that doesn't match up with the rest of the data, right? So if we go back to our chart, we say, all right, these first two intervals, right? This looks like, or even the third one, it looks like most people fall in those intervals. All right. As we move further away from those intervals, we get less and less people falling into those classes. All right. So when I say extreme, I just mean that not a lot of people, or it seems kind of extreme. I think of, if we're measuring heights, right? We would have kind of someone bunched up, like, bunched up in a certain class, but then we would say, all right, is there a 7-foot person? Well, then that would be skewed to the right. That would be like an extreme value. Right, and also on the other side, if we had a lot of people that were kind of bunched up between, let's say, 8 to like 6'1", right, then an extreme value would be maybe someone is 4'11", right, or something like that. Okay. Yes, correct. So the more popular classes are kind of bunched up together on one side of the graph, and then as I move further away, right, to the right here, there's less of them, and that would make it skewed right. All right. Yeah, it's not intuitive, Melody. I agree. Sometimes I always have to remind myself when I'm thinking of the skewed right or left, that it's not referring to the peak. It's actually referring to the smaller values, or the people that are, or whatever it is that we're measuring, to the lowest size of the classes. All right. Does that make a? Yeah. Okay. So kind of think of it that way, right? When we say skewed, it's not referring to the peak, but it's referring to the shorter ones, the smaller ones. All right. Any other questions? All right. So let's move on here. Okay. All right, so construct a histogram for the following data. So actually what I'm gonna do, I think we, just because we're running a little short on time here, and I do wanna get into this other. If we have time at the end, I'm gonna come back to this. I think we went through 2 of these, all right, and I think that's a good practice here. If we're in class, I'd have you guys construct them and I'd walk around and check on you guys, but since it's not possible here, I'm going to move on, and I'll come back to this at the end if we have some time, because I do want to get into numerical summaries. Okay, so far, all we've done, or what we've done so far, is we've looked at, we had data, and then we organize it in a visual way. All right, so what we're going to do here next is maybe some numerical summaries of data. All right, so in other words, when I mean numerical summaries, the most basic kind of statistics are average, right? When you hear the word average, now that can usually refer to one of 3 things. All right, so average is just kind of a word that is referring to, most likely, and most of the time, it's referring to what's called the mean. right? So when we think of average, we're probably thinking of the mean, right? So the mean of a set of data is the sum of the data values divided by the number of values. Okay, so if you had, and we'll run through examples, if you had 5 data values, and again, this is only referring to quantitative data, you would add them all up and then divide by 5. All right, and then here, the median set of data values, right? So the median set of data values, excuse me, the median set of the median of a set of data is the value in the middle when the data is in order. All right. So to find the median, begin by listing the data in order. And again, that's going to be important here. Make sure that in order to find the median correctly, the data must be in order from smallest to largest, or largest to smallest. All right. But it does have to be in order. If the number of data values n is odd, then the median is the middle data value. The value can be found by up to the next whole number. If the data values is even, then there is no middle value. So we can find the mean of the 2 middle values of n over 2 and n over 2 plus 1. All right, now this looks a bit confusing at first, but we'll run through an example so we can understand what the how to find the median. All right, and then the last measure of central tendency here is what's called the mode. The mode is the element of the data set that occurs most frequently. All right, so if you had a bunch of data values and let's say there were 5 2s that showed up and that was the highest number, then 2 would be the mode. Okay, the mode is not as useful when dealing with qualitative data. Excuse me, quantitative data, numerical values. When we're dealing with qualitative data, when it's more like favorite color, right, or browser, like we had in the first example when we started this section, then the mode, it makes more sense to use that. Okay. All right. So let's take a look at this example. So it says the price of a jar of peanut butter at 5 stores was, and they list these values out. All right. And it says find the mean price, find the median price. Okay. So let's start by the mean. Okay, so the mean says add up all the values and then divide by, in this case, 5, right? There's 1, 2, 3, 4, 5 data values. Okay. All right, so if we're adding these up now, here, all right, if you're using a calculator, be careful how you do this. All right, so let me turn my calculator on here. All right, so I'll turn my calculator on and then we'll add up all these numbers. So Theodore, again, you can find this set of notes. I wouldn't worry about copying this down word for word. These sets of notes are on Canvas. So I think kind of I'm gonna move along here and I'll go back to the definitions, but I would not worry about copying these word for word. You're gonna have those in front of you or they'll be on Canvas here, right? So let me kind of do this calculation first. All right, so if you're using a calculator here, so, and that would probably be our best choice here. So we'll plug in all of the values plus $3.79 plus 3.75 And then I'll close my parentheses. Oops. And then divide by 5. Okay. And then I get 3.682. So I'll round to 2 decimal places since we're dealing with money here. So the mean okay. Now, one thing to notice here is I use this notation called X bar. And X bar is used to, oops, excuse me. X bar is used to refer, it refers to the mean. All right. Okay. Okay, so that is how we would find the mean. Any questions on this? On the first part, on finding the mean? Okay. So let's look at finding the median price. Okay. Now, if we look at the median, it says begin by listing the data in order from smallest to largest. Well, let's see. Is it just 375? So again, let's list the cheapest was 329. Then the next one was 359. And the next one is 375. And then here, 379. And 399. Okay. All right. And again, you're looking for the value that divides it exactly in half, right? So here, if we look at when they're in the definition, what they're explaining here, n is odd, then the median is the middle, then the value can be found by writing up n over 2. So what does that mean, right? So that means that if we look in this case, n is equal to 5. Number of data values. Okay. So if we take 5 over 2, that's going to be 2.5. So again, we always run a round up, right? Round up to the next integer. So we round up to 3. All right. So looking at our data, again, once it's ordered, again, this only works when the data is ordered, right? We count to 1, 2, 3. Right. So that's our third data value. And that is going to be our median, right? And again, we'll label this the median M. So the median is equal to 375, right? Correct, Jorge. It was in fact 375, right? Because if you look here, right, it's the value that is right in the middle, right? Notice here that 375, there are 2 values to the right of it and 2 values to the left of it. Okay. All right. Any questions so far on the median? Okay. All right. So if there's no questions, I'm going to move on here to Yes, capital M, so this notation here. That is the median, and the N here is number of data values. Okay. All right. You always, by the total number of data values. For the mean, yes. Right. So in this case, this depends on how many, what I'm dividing by for the mean is always dependent on the number of data values. Okay. So if there was 10 of them, then you would divide by 10. If there's 30 of them, you'll divide by 30. All right. So yes, that denominator for the mean is always n. All right. All right. Good. Any other questions? So that's when there is an even number of data values, then the median would change, right? So why don't I do the next example is going to illustrate that, right? How to figure out when there is an even number of data values. When it's odd, it's easy, right? Because you always take divided by 2 and round up, and then right there, right? We're going to have 2 or whatever many, the same amount on the right as there is on the left. But if there was another data value, a 6th one, that wouldn't work, right? And I'll go over how do we do that, how do we figure that out, okay? All right, so let me actually, if there's no questions on this one, let's take a look at the next one where we have an even number of data values. All right, okay. Excuse me. All right, so here, so find the mean, the median, and the mode of the following data. The miles per gallon rating of 30 cars are shown below. Okay, so we have all this data here, and let's start with the median, since that's where we left off on the other one, and now we can just kind of continue that discussion here, right? So in this case, they tell me there are 30 cars shown, so n is 30, right? That's how many data values we have, right? So in this case, nice thing about here is it's nice and ordered for us already, so I don't have to worry about ordering the data here. So if we go back to the definition, it says there is no one middle value when the n is even. So we find the mean of the two middle values, n over 2 and n over 2 plus 1. So here, n over 2 is 15, and then n over 2 plus 1 is going to be 16. Okay, so the median is going to be, all right, let me count off to the 15th value. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15. So 15 is the 31st value, and then the 16th value would be 32. And you add those up and you divide them by 2. Right? And then that would be 31.5. Okay, and then that would be how we find the median when we have an even number of data values. All right, Jenna, did I clarify your question there? Okay, yeah, you're welcome. All right. So again, right, if we look at the definition to find the median, so to find the median, begin listing the data in order from smallest to largest. Okay, so I did that. It's already given to us like that. If the number of data values n is odd, then the median is the middle data value, and it tells you how to find that. All right, you divide by 2, then you round up. If the number of data values is even, right, so that's the case that we're in, then there is no one middle value. Okay, so we find the mean of the two middle values, which can be found like this. Now again, this is only telling you position. Okay, you take n divided by 2, and then you look at the next one, the one on the right. So how does that fit into our example here? All right, so there are 30 data values, so I take half of it, right? So I divide by 2. So that gives me 15, but since it's even, I'm gonna look at the 15th and the 16th data value. But again, right, this only works because this is in order. If it was not ordered, then I would order it. I would put it in order. Okay. All right. So I looked here and then I just started counting, right, from the beginning, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. No, it doesn't matter in the sense that I need to account for it because that's representing two different cars. Okay, so it's important to realize that those are not just representing the number 19, but actually two cars that had the mileage rating of 19 miles per hour. Okay, so they are not just one data value, it's three different cars that had that rating. Okay, all right, Jorge, does that answer your question? Okay, yeah, you're welcome, Grecia. Yes, so if n is always even, if n is even, you're gonna solve it in that manner, right? You take half, and then it's gonna be whatever whatever that number is, and the one to the right of it, the next one over. Okay, now let's look at the mean. Okay, now if I were to calculate the mean here, we would say, all right, so I know there are 30 data values. So I know I would have to divide by 30. All right, so I know that's what my denominator is going to be. So I would then have to add up all these values. We'd say, all right, 19. And to avoid repetition, I'll use multiplication, right? There's 3 of them. So remember, multiplication is just repeated addition. So it'll be 19 plus 19 plus 19. Well, that's the same as 19 times 3. All right. And then plus 20 plus 21 times 2, since there's 2 of them, plus 25 times 3. 26 times 2 plus 28 plus 29 plus 31. All right, well, we're going to run out of space here. Plus, not just times 2. It's 37 times 2 plus 38, and there's 4 of those. 41 plus 43 times 2, right? It looks a little clunky, but think of all those being on the same line, and you would divide all of those by 30. All right, so then again, I would input all this in my calculator, and at the end, I should get a result of 30.7. So the mean .7. Okay, now looking at this, I think, all right, well, this looks like very repetitive, a bit of a hassle to kind of do this every single time I need to calculate a mean for especially data sets that are, let's say we had 50 of them or 100 of them. So we're going to need to use some technology to kind of help us out. All right, so we can do this by hand, but actually I'm going to be smart about it. I'm going to say, all right, I'm going to use my my graphing calculator to help me out to do these calculations, right? So here's how we're going to do this, right? So I'm going to switch over here to my calculator, and what I'm going to do is I'm going to be smart about this, right? I'm going to tell my calculator, or I'm going to input all of my data. Now the way we do this is you go to this feature here. Where is it? Stat. All right, and you click that button. All right, and what you'll see is you'll see a menu like this. All right, and you want to go to edit, and so you can click 1, and then it'll take you to this menu here. So what you see here is L1, L2, L3. So it's a menu where you can input list. All right, so if you look, I've already filled it out, but if you look here, this is all our data. All right, it's all in there. All right, all 30 values there. Okay, so once you go through and you input all of this, you can, all right, let me get out of here. Let me hit second and quit. And I'm going to go back to the stat menu, and instead of clicking on the list, I'm going to click over to the calculate. All right, and I'm going to choose number 1 var stats. And then depending on what model of the calculator you have, and then hopefully you took my advice of checking out a graphing calculator at the STEM Center so that you can able to take advantage of this. So list is L1, so that's what I want, right? That's where all of my data was set in. All right, and then frequency list, I'm gonna leave blank for now. So I'm just gonna go ahead and enter, enter, enter. All right, and now notice what we have there, X bar, 30.66666, but if we just round to one place value, what is it? 30.7, right? Exactly what we got doing it the long way. Now it gives you a bunch of other information too. If you scroll down, Look at that. The median, 31.5. Exactly what we calculated as well. Okay. So again here, and again, there's software probably on that you can probably Google and try to find that'll do these calculations for you, right? So what we want to do here is we don't want to do these kind of just calculations by hand. We want to take advantage of what we have available to us, right? Whether that be a graphing calculator or some kind of software that we can come across the internet that'll help us do all these calculations. All right. Any questions? Yes, you can do either method. I would encourage you to learn how to use this graphing calculator, as it is going to make things go a lot faster for you. And when we start doing standard deviation, we'll see that that is a calculation that is actually best done using some kind of technology. Okay, so I know your urge right now is to think, well, I'm just going to do this by hand. I would encourage you to learn how to use the graphing calculator, and it'll be beneficial in the long run, being in the upcoming midterm. That is not a website. This is what's called an emulator. So the graphing calculator, what I'm using is what's called an emulator. Excuse me, let me write nicer here. And if you Google Wabbit, right? Similar to rabbit, but like if Elmer Fudd was saying rabbit. So Wabbit, EMU. If you kind of Google that, yeah, it's a free download. And then that you can see exactly what I have, what I showed you there on my window that I shared with you. You can have that right on your desktop or your laptop. Okay. All right. Any other questions? All right. Okay. Great. Thank you guys for joining me. All right. Bye. All right. Okay. So there's homework due not this upcoming Monday. We'll be on spring break, but the following one. Okay. And I'll make sure to keep you updated if anything changes. What about mode? Oh, the mode, of course. The mode is the one that shows up the most. So looking at our data, it appears that 38 is the mode. Sorry about that. I skipped over the mode. It's 38. Right? In this case, it shows up 4 times. All right. Okay. And again, one thing to notice is that in most cases, and this one as well, the median, the mean, and the mode will most likely be 3 different numbers. All right. Yes, this is correct. No, homework 8 and 9, the due dates are, those are correct. They'll be due a week from this upcoming Monday, the 30th. Right, I believe that's correct. Yeah. Yes, you can go back to the session. I'm gonna stop recording soon. And then from there, it takes a while for Zoom to make the recording available, but it should be available soon.